Hello everyone, welcome back to our channel. So in this video we are going to see the binary to decimal conversion. So which means we are going to convert the binary digits into a decimal. So that is what we are going to do in this video. So before we start, make sure to subscribe to our channel and hit the bell icon for more placement videos. So at first we have to learn what is a number system, right? So let's see what is a number system. A number system is a way of represent numbers. Yes, right. So we have so many ways of representing number. So here we have a decimal, and here we have a binary, and here we have a octal and hexadecimal. So we have like this, we have so many number systems. So here now we are going to convert from a binary to a decimal. So since binary to decimal we are going to convert it, and we see how to convert from decimal to binary also. So let's see what is binary. So binary which has only zeros and 1. So the computer only understands zeros and ones. In binary, we have only 0 and 1. And for every number is stored as zeros and 1. For example, if I have a 5 means, my binary value will be 101. So I'll tell you how I got this. So if I have a value 5, okay. So now I have to convert this to a binary. So how I can do means, so I can divide by 2. So what will I get? So 2 2s are 4, right? So my remainder will be 1. And if I divide by 2 again, I'll get a 1. And my remainder will be a 0 here, right? So like this we have to add. So if I add, I get a 1001. So my binary digit for 5 is 101. So next we do for the 10 also. So I have a 10. So if I divide by 2, what will I get? So I get a 5, right? So I have to again divide by 2 with a 5. So if I divide, what will I get? I get a 2, right? And here my remainder will be 1, right? So and again I have to divide by 2. So here will come 1. My quotient will be 1 and my remainder will be 0. And here my remainder is 0. So I have to add like this. So if I, for 10, I'll get a 1, 0, 1, 0. So this is how we have to convert from decimal to binary. So I'll tell how to convert from binary to decimal. So if I have a bit like this 1011110, so I have a bit like this. So I also don't know what is the number. So let's find this. So for this we have one formula. So which is 2 power 0 into our binary digit B1 plus 2 power 1 into our binary digit plus 2 power 2 into our binary digit up to 2 power n into b into n. Okay. So b into m. So this is our formula. So if you want, you can notice it. So I have take 10110. Okay. So let's do a conversion for this. So we are going to do a binary, right? Binary to decimal. So for that, I'm taking this 2 and at first I'm taking a 2 power 0 and 2 power 0 into our binary value is 0, right? And our next value, we have 2 power 1 and into our binary value 1. And next 2 power 2 into our binary value 1 and 2 power 3 into our binary value 0 here. And here 2 power 4 into our binary values 1. So now we have to calculate this. So 2 power 0 we'll get a 1. So 1 into 0 it is a 0. And here 2 power 2 is 2. 2 into 1 we'll get a 2. And here 2 power 2. So 4 into 1 we'll get a 4. And 2 power 3 is 8. So 8 into 0 it is a 0. And 2 power 4 it is 16. So 16 into 1 we'll get a 16. So now we have to add this 2 plus 4 plus 16. So what we'll get? So we get a 22. So for binary digit of 10110 is 24, 22. So this is how we have to find the binary to decimal. So let's create a class here. So inside our main class, our scanner class. So inside the scanner system.n. So now we have, so let's first do the, so we have to get a two input. One is binary, another one is decimal, because we are going to convert from decimal to binary and binary to decimal also. So for that, uh, at first in our printing statement, let's just give like enter a binary number. Okay, enter a binary number. So after that, let's get the input. So let's give int bin equal to sc dot next. So and after that, let's get the input for our decimal also. So for that, let's give a enter a decimal number. So for that also, let's get the number. So let's do for a binary conversion, and next we code for the decimal number. Okay. So let's do for binary to decimal. So for that, let's take a variable decimal. Okay. So I'm initializing with the 0. And after that, I'm taking a base, and my base equal to 1. Okay. So in a while loop, I'm just giving this bin greater than 0. So it should not exceed the 0. So that's why I'm giving this condition. So inside I'm just creating another one. So which is interim, which is a reminder. So in that I'm just taking my last digit of my value, and in a decimal variable I'm just doing a addition. Okay. So decimal plus reminder into base. And let's divide our bin. So bin by 10. And base. So inside a system, so inside a prediction, I'm giving a binary to decimal. So we have do for the binary to decimal conversion. So let's do for decimal to binary conversion also. So once I code it, I'll explain you clearly. So here I'm initializing a string. Okay, for decimal to binary. For decimal to binary, I'm going to initialize a string. So I'm just giving a using a string binary as my variable. Inside, I'm just storing a empty string. So here in a while condition, I'm just checking. So the deck greater than 0. So again, and another one variable I'm declaring, right? Like it is interim. So in a interim, I'm just giving a decimal divide by 2. So it means taking our last input. No, decimal divided by 2. So I'm just going to divide each and so I'm going to divide it divide by 2. So I'm going to divide the decimal value by 2. So now binary I'm just storing rem plus binary. So at last I'm just dividing a deck divided by 2. So I'll explain this. Here I'm just declaring decimal equal to 0 and base equal to 1. So because I have tell the formula right for converting binary to a decimal. So at first here we are just removing our last number. So if I have a binary, as a 101, okay. So here I just remove a last value. So if I give 101 divided by 10 means I'll get a 1, right? So here what I'll do means I'll add this 1. So it means my decimal value is 0, right? So 0 plus 1, what will get? So I get 1. So into 1. So my base value is 1. So I'll get my answer as a 1. And after that, so I have to remove a last number because I have to do a calculation for that, right? So I have to remove. So for that, I'm using a bin division 10. So here I will get only 10. So at last, I'm going to do for base value, I'm going to do with the multiply with 2. So my base value is 1 now. So I'm going to multiply with 2. So I'll get the 2 here as my base. So and after that here 1 not so 10 greater than 0. So the condition is true, right? So here our next iteration what will get means so we'll get a 10. So if 10 divided by 10 means we get a 1. So here we'll do a calculation. So now our decimal value is 1. Already it's a 1. So 1 plus our remainder is 1. So 1. And after that what we have a base. So at base we have a 2. So into 2 we'll do, right? So what we'll get? So here we have 2. So 1 plus 1, 2. So 2 into 2 we'll get a 4. So here we'll get remainder as 0. Right? So here what we'll do? Our decimal value is 1 and our remainder value is 0. So 1 plus 0 which is 1. So and so 1. So 1 into base, our base is 2, right? So 1 to so into 2. So what we'll get? So here 0 into 2 it become a so here we have a 1 plus 0 into 2. So we all have a rules for precedence, right? So here we have a plus and multiplication operator. So in the order of board most at multiplication will execute first and after that only we get a plus operator. So at what we'll get? So at first 0 into 2. So 0 into 2 is 0. So and after that we'll add 1. So here 1. So our value will be 1. So here if we do a 10 divided by 10, we'll get a 1. So now our value. So our base value. So it is still 2. So 2 into 4. So it become 2 into, so our base value is 2. So 2 into 2 will get a 4. So again we'll get a 1. So 1 is greater than 0. So the condition is true. So again we'll come here. So here now we have only 1. So if I divide by 1 divided by 10, what will I get? So I get only 1 as my remainder. So here, so my decimal value will be, so my decimal value is 1, right? So here I have only 1. So my remainder is 1. So and into base value. So what is my base value? At base value I have a 4. So I have said according to the precedence what we'll get. So here we have 1 into 4 and 1 plus 1. So how we'll do means, so at first we do a multiplication operator. So 1 fourth of 4 plus 1 we'll add it. So we'll get a 5. So again it become a 0. So if we divide it become a 0 and base value become a 8. And here the condition is 0 greater than 0. So the condition fails. At last we'll just print the decimal. So we take a 5. So here we'll get a 5 as our value. So let's run this. So we have to enter binary to number, right? So we have to enter a binary number. So let's give a 101. So and after the our decimal value, let's give it as a 5. So what we got? So if we convert binary to decimal, so we have 1001. So which is a value of 5. And if I enter decimal as 5, I'll get a value of 1001. So successfully we have executed. So do the iteration for the decimal to binary. So it will help you to understand. So I have do for the binary to decimal, right? So you try yourself for decimal to binary iteration. So it will be very helpful to understand this problem. So because this problem comes in programming, data structure and digital electronics and placements also. So if this helped you, like the video and share it with your friends and subscribe for more easy programming tutorials. So see you in the next video.